Hello viewers, in today's session we are going to discuss an important integral involving the signum function and absolute value function, right? So here in this class we are going to evaluate this integral which is from -1 to 1 e raised to mod of x, and then we have signum of x square plus 1 dx, right? So what we will do in this problem, we'll utilize the definition of mod function and the signum function. So let us start. So let us first take this term, that is signum of x square plus 1, right? So here let us first see the definition of signum function. We know that signum of y is defined as positive 1 whenever y is greater than 0, and signum of y is 0 when y is equal to 0, and signum of y is negative 1 for y less than 0, right? So this definition says that for all positive y, we have the value of signum of y as 1, and for y is equal to 0, signum of y is 0. It means signum of 0 is equal to 0, right? And for all negative values of y, signum of y is negative 1. So now let us take a signum of x square plus 1, right? So signum of x square plus 1 is always equal to positive 1, right? Because see, here signum of y is equal to plus 1 for all positive values of y. And see, here we have x square plus 1. So if we take y is equal to x square plus 1, then x square is always a positive quantity irrespective of the value of x, right? So x square is always greater than or equal to 0. So x square plus 1 is always greater than 0. It means x square plus 1 as a whole is always a positive quantity, right? So here the argument x square plus 1 is always a positive quantity when x goes from -1 to 1, right? So when the limits goes from -1 to 1, so for all values of x which belongs to the interval -1 to 1, including -1 and 1, x square plus 1 is always a positive quantity, right? So signum of x square plus 1 is always positive 1. So now we can write -1 to 1 e raised to mod of x, and here we have plus 1 for signum of x square plus 1. So here we have dx. Now we'll make use of the definition of mod function. So now mod of y is defined as a positive y whenever y is greater than or equal to 0, right? And mod of y is negative y whenever y is less than 0. So this is the definition of mod function. So here we have the limits of integration goes from -1 to 1. So here we have -1, here we have 1, and here we have 0 between -1 and 0. So what we will do, we'll break this integral in two parts. The first one is from -1 to 0, and then from 0 to 1, right? So here we have -1 to 1 e raised to mod of x, because e raised to mod x multiplied 1 is simply e raised to mod x, and here we have dx. So the first integral is from -1 to 0. So here we have mod of x dx, and here from 0 to 1 we have e raised to mod x dx, right? Now see, when x goes from -1 to 0, it means all the values of x are negative, right? So mod of x is now defined as a positive x for x belonging to 0 to 1, right? And mod of x is negative x for all x belonging to minus 1 to 0, right? So here a mod of x is negative x because x goes from minus 1 to 0. So we have minus 1 to 0 e raised to minus x dx, and here we have 0 to 1 and e raised to positive x because mod of x is positive x when x belongs to 0 to 1, right? So here we have dx. So now we have two simple integrals. So here the integral of e raised to minus x is minus e raised to minus x. Limits are from minus 1 to 0. And then we have the integral of e raised to x as e raised to x, and the limits are from 0 to 1. And now we can take this negative sign outside. We have e raised to minus x minus 1 to 0. And here we can substitute the limits and we'll take the difference. So when x is 1, we have e raised to 1. When x is 0, e raised to 0. And here we have x is 0. So here we have e raised to 0. Then we have x is equal to minus 1. So minus and minus becomes plus. So here we have 1. And here we have e minus 1 because e raised to 0 is 1. So here we have minus e raised to 0 is 1 minus e plus e minus 1. So this is minus 1 plus e minus 1. So I is equal to 2e minus 2, right? So e plus e is 2e, minus 1 is minus 2. So I is 2 times e minus 1, where e is the exponential number, right? So viewers, the value of this integral is equal to 2 times e minus 1.